So note in our drawing that we don't have any parallel markings, right? We don't have any little arrows that prove to us that these are parallel lines. So don't assume it. What we're being asked to do in this problem is what value of x would make these two lines parallel. Well, we know what type of angle relationship is this. Is it corresponding, alternate interior, alternate exterior, consecutive interior? They are consecutive interior angles, and by the consecutive interior converse theorem, they would add up to equal 180 degrees because they are supplementary. We can combine these like terms and divide both sides by 5, and we get x equals 36. So if x were 36, then that would make these lines parallel to each other, because that forces those two angles to be supplementary. Mr. Over, we never talked about parallel rays. Don't trip. I mean, if you want to just make them lines, then make them lines, right? Same thing with these. You can just make them all the way across. But now this becomes a more intimidating problem. So let's ask first, is EB parallel to HD? Well, let's focus on EB and HD. So if these were like parallel lines, right? I mean, if you want to just make these lines, and if these were parallel, these are like corresponding angles. And if the corresponding angles are congruent, then yes, these lines would be parallel. However, I don't know how you feel about this, and it doesn't matter how you feel about this. Are these angles congruent? And if they're not, then these lines are not parallel. I should say rays, right? Because the original problem is talking about rays. So according to the corresponding angles converse theorem, these corresponding angles are not congruent, and therefore these rays are not parallel. What about EA and HC? Well, let's focus on these rays, right? And let's see if these are, if we extend these lines, these are our theoretical parallel lines, right? And here's our transversal EHG. What is the measurement of this angle right here? Well, by the angle addition postulate, these two angles would add up, and that equals 120. And if we look over here and we add up these two angles, we also get 120 degrees. Interesting. So these are corresponding angles, and they happen to be congruent. So interestingly enough, for ray EA and HC, because of the corresponding angles converse theorem, it states that if the corresponding angles are congruent, then the lines are parallel. So for problem 4, the answer is yes. These are parallel to each other, right? I'm going to put little arrows showing that they're parallel to each other. Again, notice that in these diagrams, we don't have these little arrows symbolizing that these lines are parallel. We don't know that. We have to go ahead and prove that using a converse theorem, right? Those are the 4 ways to prove the lines are parallel by those 4 converse theorems in the front page. So is line AC parallel to DF? Well, let's do some digging. What they gave us, this angle and this angle right here, these are not corresponding angles. They're not alternate interior angles. They're not alternate exterior angles. And they are not consecutive interior angles. However, this does form a linear pair. This also forms a linear pair. And we know that a linear pair is supplementary. And for it to be supplementary, it means it up to 180 degrees. So if I take 180 degrees and subtract it from 143, it's going to be 37 degrees. Interesting. So this angle is 37 degrees. Hey, this one's also 37 degrees. Hey, these two angles are corresponding angles. So if the corresponding angles are congruent, then these lines must be parallel. So are they? Yes. What is the justification? Well, I'm not going to write it down, but I will say it for you to write down. We are using the corresponding angles converse theorem. We were able to prove that the corresponding angles are congruent, and if they're congruent, then the two lines must be parallel. By the way, a quick plug into something that I've been kind of mentioning for a while now. Geometry is very vocabulary heavy. And so if you're feeling overwhelmed with what is what, it's because you haven't been keeping up with your vocabulary, with your theorems, etc. So now would be a good time still to go back and make sure you maybe have a list or note cards or flashcards or your notes, right? Where you have vocabulary, where you have like a cheat sheet so you know what these words are, because you're not expected to remember everything, but I am expecting you to use your notes to help you to remember things. So for example, we talked about linear pairs right now and supplementary and corresponding angles, and if you don't know what these words are, then nothing of this is making sense. So please take the time to invest in a list of vocabulary or just something that you can go to where if I bring up a word, you can go back and look. Okay? I'll do my best to, of course, redefine things as we use them. Problem 6. What value of x would m be parallel to n? And once again, you note that we don't have little arrows on these lines signifying that they're parallel. We don't know these are parallel. We're being asked what value of x would allow us to say that m is parallel to n. There's 4 ways to prove that these two lines are parallel. And in this particular case, we see that this angle is given and this angle is given. And these are alternate interior angles. So by the alternate interior converse theorem, these would be equal to each other. And if they're equal to each other, then the lines would be parallel. Question is, what is its value for x? Well, we're going to go ahead and do basic algebra like we have been for a cool minute. And this is going to be equal to x, and this is going to be equal to 20. So if x were equal to 20, then it would force these angles to be congruent to each other, and therefore the lines would be parallel by the alternate interior converse theorem. Remember, the converse theorem says, hey, if these angles are doing these things, then we know the lines are parallel. For your summary, what algebra was used in the above problems?